The rains come almost like clockwork. For this is St. Petersburg, Russia, a place where on average it rains almost every third day. For months on end it is raw, damp, and cold there, umbrella and coat weather. The climate of this northwestern Russian city is clearly unlike the desert lands of Jordan, with their bone-dry sands baked under a brutally hot sun. The sky remains cloudless for months at a time in this foreboding land. Of course, there are days in many places throughout the world when it is warm and dry, but on other days cool and overcast, and still other days cold and snowy. In the short term, rain or snow, heat or cold, is a place's daily or weekly weather. A place's climate, on the other hand, is its weather averaged over a long time, decades, hundreds, even thousands of years. Climatologists, people who study climates with weather balloons, specially equipped airplanes, satellites, and other devices, often divide the world into 6 principal climate regions: dry, tropical, temperate, continental, polar, and highland. In tropical climates, it's hot year-round, with frequent rains, although in some tropical regions there are periods with no rainfall. Many dry climate regions have very little precipitation and little or no plant life. Deserts are found in dry climates, as are steppe areas, which often border deserts. Steppe regions have slightly more rain and are often covered with scrubby plant growth. In both steppe and desert areas, temperatures swing widely between daylight and nighttime hours. Next, the temperate climate, where summers are often warm and the rest of the year cool and mild, with long periods of rainfall. Summers are also warm in continental climates. They're humid, too. Winters in continental climate areas are often cold and snowy. Precipitation, snow in the cold months, rain when it's warm, is distributed somewhat evenly throughout the year. Polar areas have short, chilly, and often rainy summers, and very long, cold, blustery winters. Finally, there are highland climates, whose temperatures vary according to elevation. Specifically, the higher one goes, the cooler it becomes, because air, which holds heat, becomes increasingly thinner at higher altitudes. In fact, altitude is one of 5 major factors that affect climate. If you walked up a mountain pathway, for example, you would find that the temperature would drop 3.5 degrees Fahrenheit for every 1,000 feet you climbed, or 6.5 degrees Celsius for every 1,000 meters. Another of the 5 factors that affect climate is latitude. Because the sun's radiant energy shines directly on areas nearest the equator, that is where the warmest areas of the Earth are found. Farther to the north and farther south, the angle of sunlight becomes smaller, so there's less heat from the sun at those locations. At the North Pole and South Pole, the angle of sunlight is so small that very little heat finds its way to the Earth's surface in those places. Latitude takes on added importance as the Earth makes its annual journey around the sun. That's because the Earth tilts roughly 23.5 degrees on its axis. So when it's at this position in July, it's summer in the northern hemisphere, because the sun's light and heat is aimed more directly there. At the same time, it's winter in the southern hemisphere. Half a year later, in January, when the Earth's position is here, it's just the opposite. Now the sun's light and heat are aimed more directly at the southern hemisphere, so it's summer there, and winter in the northern hemisphere. Now, On to the third of the 5 factors that affect climate, the Earth's topography, that is, its surface features. Mountain ranges are an example of a topographical feature that can play a major role in a climate's precipitation levels. As humid air moves in from an ocean and then sweeps upward across the mountain slopes, the air cools, and the moisture swept off the water begins to form a cloud. As the tiny water droplets in the cloud come together, they become heavier and then fall to the ground. As the air skims down the other side of the mountain, it heats up and the cloud vanishes. The side of mountains facing away from oceans are often dry. In addition, a so-called rain shadow may stretch more than 100 miles downwind from a mountain range. Rain shadow areas are known for their dry lands and dry air. Oceans and large lakes, the fourth of the 5 factors that affect climate, often moderate what might otherwise be more extreme weather conditions. An example occurs in San Francisco, California, on the shores of the Pacific Ocean. San Francisco and St. Louis, Missouri, a city some 2,000 miles or 3,300 kilometers to the east, lie at about the same latitude, and so get about the same amount of solar energy each year. Yet San Francisco's climate is much less extreme than that of St. Louis. Summers are mild and winters are cool there, while in St. Louis, summers can be blistering hot and winters very cold. The difference is the moderating winds that blow off the surface of the Pacific Ocean. They act as a kind of giant air conditioning system. Or take the case of the British Isles, which for the most part have mild summers and cool and rainy winters. The northern tip of the Isles is located on a latitude that runs north of Moscow, Russia, a city that has cold, snowy winters and very short, cool summers. The contrast is caused by the warm ocean waters that flow by the Isles, waters that originate off Africa's west coast near the equator. Now, on to the Earth's winds, the last of the 5 factors we'll discuss that affect climate. There are 6 belts of winds that encircle the Earth. They push along warm and cold air masses, moisture, storms, and pollution. What are called trade winds meet near the equator, causing air to rise. As it does, rain clouds form. This band of cloudy, rainy weather near the equator is known as the doldrums. Up to this point, we've discussed the Earth's major climate regions: polar, continental, highland, temperate, tropical, and dry. And we've also discussed the 5 key factors that influence those climates: altitude, latitude, topography, oceans and large lakes, and the Earth's winds. Now we're going to discuss climate changes. There are several events that shift climate patterns for a short time, perhaps a year or so. One is when the temperature of ocean waters change, specifically in the Pacific Ocean, where in normal times cold water streams move upward to the surface, like this. The trade winds blow the surface waters westward. But when the streams move downward, the cold waters do not reach the surface, at least not as much as before. So surface waters become warmer than normal, as shown by the orange and yellow pattern. This warming is part of what's called an El Niño event. During El Niño periods, the westward moving trade winds weaken. and the warm surface waters of the Pacific, which help create rainfall, spread to the east. Meanwhile, rain clouds disappear in the western Pacific without the arrival of the moisture-laden trade winds. This lack of rain results in severe droughts in the western Pacific, as well as a large number of range fires, fed by dry grass. At the same time, flooding often occurs in Peru in South America, where the warm, moist air builds up and then falls back to earth as rain. Some of that warm, moist air also moves northward to North America, where winters in the Midwestern U.S. often become mild and more damp than normal. Sometimes the cold water stream surges upward at a greater degree than is usually the case. In these so-called La Niña events, cold surface waters, seen in light blue, spread to the west. The warmer surface waters at the head of the surge, in orange, are pushed westward by trade winds, and heavy rains and stormy weather are seen more frequently in the western Pacific regions. Besides variations in the flow and temperature of ocean waters, volcanoes can cause short-term climate changes too. The thousands of tons of sulfuric particles that are thrown into the atmosphere when a large volcano erupts can spread thousands of miles as atmospheric winds carry them across the globe. These particles can block sunlight and, in doing so, can lower temperatures. Activity on the sun also affects climate. Many scientists believe that sunspots and solar flares may increase the Earth's temperature temporarily. Many scientists also believe that increased amounts of the gas carbon dioxide in the Earth's atmosphere may be responsible for global warming. Carbon dioxide is a byproduct of burning fossil fuels to heat and cool buildings. Carbon dioxide also comes from burning gasoline and other fossil fuels to run cars, boats, trains, and airplanes. Carbon dioxide, or CO2, slows the escape of heat from the Earth's surface by radiating it back to the ground. During the past 150 years, it's estimated that the atmospheric carbon dioxide level around the Earth has increased about 25%, in part a result of increased fossil fuel use, and in part the result of rainforest destruction. Rainforest trees absorb carbon dioxide. Now that you know about the Earth's climates, let's see how they affect living patterns. First, climate affects what people eat. For example, in tropical climates which support rainforests, people often have a ready-made food supply. All they have to do is harvest and prepare edible vegetation that grows wild. Of course, many plants do not grow well in tropical climates. Wheat is an example. Wheat grows best in continental and temperate climates. These are the so-called breadbasket regions of the world. Staple foods in these regions include bread, and one of the many pasta or noodle variations prepared throughout the world. Climate also affects how shelters, houses, and other buildings are constructed. In tropical climates, especially in areas where there is little power for air conditioning, shelters are often open-air buildings that allow breezes to move through interior spaces. Bricks thick enough to repel the sun's equatorial heat also may be used in hot climates. In either case, roofing material is generally non-porous to keep frequent rains from getting inside. In regions that support forest growth, such as those in highland and continental climate areas, lumber is often used to construct shelters. Clothing, too, is affected by climate. In the northern parts of continental climates, where it's often chilly and where precipitation is frequent, people commonly wear coats and jackets. By contrast, such clothing is practically never seen in tropical climates. It's simply too hot there to wear heavy coats and jackets. Climate also affects recreational activities. In sunny, warm areas, people often pursue diversions that allow them to take advantage of the temperate weather. Where it's cold and snowy, recreational activities take a decidedly different turn. As you undoubtedly have noticed, water plays a key role in climate and the way people adapt to weather conditions. Water is the most common substance on Earth. It covers 70% of our planet's surface in oceans, seas, lakes and ponds, rivers and streams. Water is found in our atmosphere as clouds. Water means life. Every living organism is primarily a vessel for this precious substance. An elephant is about 70% water. A caterpillar is about 80% water. And a tomato, 95%. We human beings, our bodies, are almost 2/3 water. We need to replenish our body's supply of water by taking in at least 2.5 gallons or 2.4 liters of liquid every day. Under certain conditions, most people can live almost 2 months without food, yet only about a week without water. The amount of water on Earth, along with the water in the Earth's atmosphere, is constant. It never changes. It is merely recycled again and again in what's called the water cycle. Clouds form from water vapor evaporated from the Earth, mostly from oceans, but also from rivers, moist land, and plants. The clouds are often pushed along by winds to distant locations. In time, conditions are favorable for the water to drop back to Earth as rain, snow, sleet, or hail. The water drains into lakes and rivers and eventually back to the oceans, and the cycle is repeated. Water has many different uses, of course, generating electricity in hydroelectric plants, watering crops, cooling radioactive material in atomic energy facilities, becoming the liquid for soft drinks. The list is almost endless. Nevertheless, in time, it always returns to where it can evaporate skyward, where eventually it will find its way into a cloud and then back to Earth. Although our planet's surface is 70% water, only 1% of it is used for drinking, cleaning, irrigation, and manufacturing. That's because 97% is ocean water, too salty for humans to drink and use in other ways. Another 2% of the Earth's water is locked in ice, which leaves again only 1% for human use. Yet there is still plenty of this precious liquid for everyone, even when considering our use of water has doubled during the past 2 decades. The problem with water is that it isn't evenly distributed around the world. In desert areas, of course, there's very little precipitation. And from time to time, droughts appear in areas that normally have plenty of rainfall. As we've mentioned, sometimes these droughts occur during El Niño periods. Droughts can have devastating effects. A particularly cruel one hit South-Central Africa several years ago. Countless animals died there as water supplies dried up. The toll in human death was even more tragic. Today, artificial lakes and other facilities have been built by some governments to help cushion the effects of droughts. Facilities that take salt out of ocean water and water conservation programs help also. All of this points to the clear fact that water plays a major role in living patterns. In some areas of the world, such as the Amazon River basin in South America, water is the principal means of transportation. Young people travel to and from school in canoes, not in school buses or cars. Moreover, river transport is about the only way to move trade items, everything from eggs from the family farm to lumber. The river also dictates how shelters are built. Because the Amazon's water levels move up and down according to tides and rainfall, houses are built on stilts. Far to the north in western Canada, water plays an equally important role in the lives of the Nisga'a Indians. Many of their native dances and music tell about the river and the fish that live in it. In local schools, river and fish stories, an important focus of tribal folklore, are recounted to youngsters in an attempt to foster traditional Nisga'a culture. Besides playing a role in folklore and the performing arts, water often plays a key role in a region's economy also. Many cities, such as Chicago, Illinois, have been built where water is plentiful, for people, for transportation, for power generation, and for industry. And of course, water plays a key role in the economy of agricultural regions worldwide. What it all boils down to, then, is that our world has many different climates. Those climates are the result of latitude, altitude, topography, oceans and large lakes, and global wind patterns. Climates change due to shifts in ocean temperature, volcanoes, activity on the sun, and increases in the amount of carbon dioxide in the air. In addition, the Earth's water supply, which remains constant, often plays a major role in a region's transportation, its architecture, performing arts, folklore, and industry. Climate and water, they are two key factors in the study of geography.